That was number 7. Okay, the next one is 11. 11. Get rid of this. Eleven says, in unit vector notation, what is the sum a plus b? And then it gives us a and b. Okay? Let's talk about the vector a. So here's vector a. Ugh. Green is ugly. Okay. Vector a is equal to 4i plus 3j. Okay. Vector b is equal to negative 13i plus 7j. All right, well, let's do a plus b and see what happens. So to add a plus b vector, I'm going to add the i's of each and the j's of each. Just add them up. So 4 minus 13 is negative 9i, plus 7 plus 3 is 10j. It's that simple. So let's draw it. So I have 9, so I have negative 9 here for the length. So it's 9 in the x direction, negatively, and then 10. There we go. That's it. If I want to add them together, I'm going to take this one and slide it over, or take this one and slide it up. I'll just use that parallelogram method really fast. Okay, if I make a parallelogram, then the diagonal is the resultant vector. All right, so this is the a plus b vector. So the magnitude of a plus b vector squared is equal to a squared plus b squared. So a plus b vector, all right. So we have 9 squared plus 10 squared, that's 81, that's 100, so square root of 181, 13.5. All right, so that makes sense. If this is 9, this is 10, this one could be 13 long. That's reasonable. And then to get the angle, again, the tangent of theta, okay? This time, where are we measuring it from? What is the magnitude in the direction? All right, so we'll just measure it. We'll measure this one here, okay? So tangent theta is going to be equal to the opposite divided by the hypotenuse. So we have 9 divided by 10. Theta is equal to the inverse tangent of 9 divided by 10. Now, this should be close to 45 degrees, right? Because if this were 10 and 10, or 9 and 9, it would be 45. Mine's a little jacked, but we got 41.8 degrees. Okay? That seems to work pretty good. All right, let's keep going. P15. Let's look at the long one. There's a drawing. I'm going to check my notes here. There's an XY axis there. And then we have one vector drawn 30 degrees. Okay, and then that's good. And then another one that's drawn. So this is the B vector here. This is the A vector. Okay? All right. Well, they have equal magnitudes of 10. This was not long enough. Okay, so they're both 10 long. It turns out that this is a 30-degree angle here. If you were to continue this on, this angle between those two is, let me check that. It says theta 2 is equal to 105. So this is 105 degrees. This is 30 degrees. This is 10 long. This one is also 10 long. Just a quick so if I just do a little bit of geometry on this, I do just a little bit of geometry. That's 105. If I were to draw another axis here, we see this is 30, which means this angle in here is also 30. Again, alternate interior angles. So 105 plus 30 is 135, which means that this angle here is 45. So this is a little bit of geometry to help us understand the problem a little bit better. Okay. So the question is, find the x, y components of their vector sum and the angle that it makes. So we're going to add them together, and then see how long it is, and then what angle it makes. No problem. So we're going to employ this idea here, that if I want to find the vector a plus b, I'm going to take the vector a and I'm going to add it to the vector b. Now, when you write it like this as all three vectors, you're implying that you're adding them tip to tail, which I'm doing. But what this means also is to get this, when I add these together, I'm going to get the ax plus the bx, and then the a in the y direction plus the b in the y direction. Now, that's why it's easier to write this in unit vector notation, because it's like ai plus bi plus aj plus bj, like that's the same thing. So I'm going to get the components, I'm going to add the components together to construct my, my vector. So let's do this one here. So the components are horizontal and vertical. So that's the a in the x direction. That was the a in the y direction. And I have the hypotenuse and the angle, so I can find those. So I know that my, if you look here, the cosine of my angle, and we'll use theta here, is equal to the adjacent side, which is ax, divided by a. So then ax would be equal to a cosine theta. So in this case, 10, a vector is 10 long, times the cosine of 30. So my a in the x direction is equal to, it's got to be like 8.67. Hopefully that red's not too hard to see. Let's try a different one. If I use sine, well, that's much better. Sine of my angle, theta here, is equal to the ratio of the a in the y direction, which is here, divided by the a. So a in the y direction is a sine theta. So a in the y direction is equal to 10 sine 30. Sine of 30 is a half, so ay is equal to 5. So this side here is 5, this side is 8.67. And visually and graphically that makes sense. Like this is, those are both smaller than 10, this is half of that, so I drew it okay, it looks pretty good. Let's do this one up here. When I go to get the components of this guy, I know it's vertical and horizontal. Now the thing about this though is I want you to notice this is pointing to the left, so we're going to actually have to subtract that up there when we get there, but let's see if we can't get these guys. So this is if this is 45 and this is 90, this is also a 45-degree angle, which is cool. So this is B in the y direction, this is B in the x direction. So if I use the same understanding of this here, my B in the x direction should be equal to, well, this time the B is across here, so we're going to use the B sine theta, because the angle we chose here is across, so we have to use the sine. So Bx is equal to 10 sine 45, and so Bx is equal to 7.1. But because it's a 45-degree angle, what does that tell you about By then? By is also equal to 7.1. So inside this up and down here is 7.1, and this one here is negative 7.1 because it's pointing to the left. So let's go back and get our vectors then. How do you express the a plus b then? Well, my a in the x is 8.67. Okay, and then I have to subtract 7.1. The y components are 5 plus 7.1. So how do I express my vector? All right, I'll switch to unit vector notation so that it makes some sense here. So 8.67 minus 7.1, this is 1.57, and that's in the I direction, plus 12.1 in the j direction. So that's my vector. And this vector, I'm going to draw it in brown here. So this is the a plus b vector, and that's here. Because those are arranged tip to tail, and let's see if that makes sense. In the x direction, it's only about 1.5 over, but it's 12 high. So graphically, this makes some sense. So if I want to get the magnitude of a plus b, it's going to be equal to 1.57 plus 12.1. And do the math, and you end up with, well, 12.2. It's not very much bigger because the vertical component, right, this vertical component here is 12.1. And it's only angled a little bit, so it's only slightly a bit longer at 12.2. And again, if you want to get the angle, I'm going to use the tangent of the angle. Let's see, what angle do they want here? Let's do this whole angle here. Now I'm going to use this Greek letter here. That Greek letter there is phi. So let me get rid of this. So phi there. The opposite is going to be that whole side there. So it's that whole side and the adjacent. All right, so I have the opposite side is 12.1 divided by 1.57. I'll take that, and I got 82.5 degrees. And that seems like it's very close. It's really close to 90 because it's so big. Right, that makes a lot of sense. Yeah, because that was a hard one. Oh, okay. So we're going to do 17. We're not going to do all of 17. We're just going to do 17A because it's the same process over and over. and it's a little tedious, so let me get ready for 17. So I have an XY axis here. So here's my XY axis, and I have three vectors, A, B, and C. And the A vector each has magnitude of 50 meters and lie in the XY plane. This one's 30 degrees, all right? So A is 30 degrees. Here we go. Meters at 30 degrees. And then the next one, it says the B vector is 195 degrees. So this is 0, 90, 180, so this is about 15 degrees. Okay, so that's 50. That in there is 15 degrees. Okay. And the last one it says is, the C vector is 315 degrees. So that's 315, so that's here. So that's 50, and that makes this angle 45 degrees. Okay, so now we have our vectors. And basically it says, can we find A plus B plus C? I think we should be able to do that. That shouldn't be a problem. So graphically speaking, if I wanted to add these together, I could take my A vector, leave it where it is, and would take my B vector and put it at the tip here, and then put the C vector at the tip there. So we could do it graphically, but in this case it's actually easier if we just do, if I want to do A plus B plus C vector, I'm going to take the vectors A plus vector B plus vector C, which means I can find the components and just add the components up. So this is then AX plus BX plus CX plus, and that's going to be a number, AY plus BY plus CY. So that means we need to find the components of each of these, which we can do. It's well inside our skill level now. So let's do A. So if I look at A, so we have AX and AY here. So I'm just going to use my standard. Now we're starting to get the hang of these things. So A in the X direction is equal to A cosine theta, because AX is the adjacent side, so no problem. So then AX is equal to then 50 cosine 30. So what's AX equal to? That's 43.3. AY is equal to A sine theta. Sine 30, so AY is equal to 25. All right, let's do the B vector. So I'm using it gave us the angle measured from the x-axis, but I'm just using the referent angle here because it allows me to explore the components a little more easily. So this one here is BX, this one here is BY. So B in the x direction is equal to B cosine theta. So that's 48.3. Now, you see though it's pointing to the left, so we're going to include the negative. by is equal to b sine theta. 50 sine 15. It's 12.9. But this one points down, so we're going to include the negative sign on that one also. And what about my red? So this one's cool. So c in the x direction is equal to c. Ooh, got a little excited there. Sorry. C cosine 45. That's going to be 35. 35.4. Now, that's CX. Because it's a 45, 45, 90 triangle, I know that CY is the same thing. But notice CY points down, so we're going to make that one negative. And now I have all my components, I'm just going to put it in here. Sorry, I'm going to move this over here so we're not confused. Okay, so this is A plus B plus C vector. All right, and so I'm going to put them in here. So I have AX, BX, and CX. So AX is 43.3. BX is negative, so negative 48.3. And then CX is positive, 35.4. Okay, and let's do the Y's. AY is 25. BY is negative 12.9. CY is negative 35.4. And again, we can write that in unit vector notation if it's easier that way. So A plus B plus C is equal to, if I add those up, $30.4. I don't need this. Minus 23.3. So there's the vector. Okay, there's the vector. And now if I want to get the magnitude and direction, to get the magnitude, so I'm going to take 30.4 squared plus negative 23.3 squared. So A plus B plus C, the magnitude of that is equal to 38.3, which makes sense in terms of it's bigger than either of those, but smaller than the arithmetic sum. And again, I'm going to get the tangent.